Welcome back. In this video, we are going to work on proving a quadrilateral means a parallelogram. And fortunately, we won't have to prove all of the properties of a parallelogram to prove it's a parallelogram. We'll only need certain things. In fact, we can prove a parallelogram is by proving just one of the following things. So we don't need all 5 of these. There's going to be 5 ways to do it, but you only need to do one of them. And which one you use will depend on what is given to you and what route you take and that type of thing. So there's a variety of ways to prove it, but you only need to do one of these. So to prove a quadrilateral is a parallelogram, if both pairs of opposite sides are parallel, then it's a parallelogram. So if we get our diagram, our 4-sided figure, our quadrilateral, to look like that, that's all we need. We've got ourselves a parallelogram, and this would be the reason that you would use in proof. Okay? Both pair of opposite sides parallel implies parallelogram. Done. You get that, you've proven it. The second one, if both pair of opposite sides are congruent, then it's a parallelogram. So if you can get your quadrilateral to look like this, to have that set of tick marks, that type of thing, then you have yourself a parallelogram. And again, here's the reason that you would use in proof. If both pair of opposite sides are congruent, then it's a parallelogram. The third reason, if one pair of opposite sides are both parallel and congruent, then it's a parallelogram. So one pair of opposite sides are both parallel and congruent. So you might have something like that. We've got one pair of opposite sides, they're both parallel, they're congruent, you are done. You have found that to be a parallelogram. Now that doesn't mean you couldn't have the other pair of opposite sides are parallel and congruent. That would also be a parallelogram. If you had something like this, one pair of opposite sides parallel, the other pair of opposite sides congruent, that is not a parallelogram. We have not proven that a parallelogram. In fact, that was an isosceles trapezoid. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So if the diagonals bisect each other, then we've got ourselves a parallelogram. So if you can get your diagram to look something like that, you've got yourself a parallelogram. And again, here's your reason in proof. Okay? And what you will see is I will probably draw everything to look like a square. And we have something like that. That is a parallelogram because the diagonals bisect each other. And our fifth reason, if both pairs of opposite angles are congruent, then our quadrilateral is a parallelogram. So if we can get both pairs of opposite angles congruent, then we have ourselves a parallelogram. So let's take a look at a sample problem here. We're given that ACDF is a parallelogram. So ACDF, this whole big thing, is a parallelogram. And then we've got angle AFB is congruent to ECD. And now we want to prove that FBCE, this thing on the inside, is a parallelogram. Okay? So, what are we going to do here? There are so many things that go along with this given. This ACDF is a parallelogram. We're given that. So there's plenty of implied information here, but what is going to be the most helpful? And also now we want to prove that this is a parallelogram on the inside. Well, there's all sorts of ways, right? We can use the opposite angles, or we can draw in diagonals and see if we can get them to bisect each other. You know, we get one pair of opposite sides congruent and parallel, or we could try and get both pairs of opposite sides congruent, or both pair of opposite sides parallel. So we've got a lot of choices here. The question is which route is going to be best for us and is going to be easy for us to prove. So I think what I'm going to try and do is I'm going to try and prove these two triangles congruent. I think that's really going to help me out. So let's see how we do here. ACDF is a parallelogram. So if I want to prove that these triangles are congruent, don't I know that AF is congruent to DC? So AF is congruent to DC, and I know that because parallelogram implies opposite sides congruent. Looks like my notes are running into each other here. And it looks like I can probably get these triangles congruent by angle, side, angle, because I know that in my big parallelogram here that the opposite angles are congruent. I know that angle A is congruent to angle D because the parallelogram implies that the opposite angles are congruent. And that gives me, I'm going to watch my correspondence here, triangle FAB congruent to triangle CDE by angle, side, angle, and that would be steps 1, 3, and 4. Well, I know that AB is congruent to DE because they're corresponding parts of congruent triangles. So I have AB congruent to DE. And don't I know that FD is congruent to AC? I'm going to do a little subtraction here. FD is congruent to AC because opposite sides of a parallelogram are congruent, so that is going to be the same as 3. Parallelogram implies opposite sides congruent, and I'll get FE congruent to BC. By subtraction. Congruent. If congruent segments are subtracted from congruent segments, their differences are congruent. So now I have FE congruent to BC. So I have one pair of opposite sides congruent. And wow, I could do one pair of opposite sides parallel and congruent. I know that FB is congruent to EC because of CPCTC. So now I've got two good reasons for proving this is a parallelogram. It's just a matter of picking which one I want. I will probably do the little bit more difficult one. FD is parallel to AC. I can say that FD is parallel to AC because a parallelogram implies opposite sides parallel. And then step 10, then I know that my figure is a parallelogram. FBCE is a parallelogram because I have one pair of opposite sides are both parallel and congruent, and so that implies I've got myself a parallelogram. If you decided to use both pairs of opposite sides congruent, that is fine as well. You could do that. All you would need then is FB congruent to EC by CPCTC, and then you've got both pairs of opposite sides congruent. That also implies a parallelogram. So a really good sample problem there with some variety to it. Definitely the properties of a parallelogram came shining through, and so that was really good practice for you. And we'll work on this more when I see you in class.